Microsoft Aspire versus Kubernetes. In this blog post, Microsoft Aspire versus Kubernetes for Cloud Apps Practical Guide, we will compare what each tool is for, how the underlying technology works, and how to choose the right approach for your team. If you're building modern cloud apps, the Microsoft Aspire versus Kubernetes for Cloud Apps Practical Guide question usually comes up when you want faster development without losing production-grade reliability. At a high level, Microsoft Aspire is a developer-focused toolkit for composing and running distributed applications locally and in dev test environments with strong .NET integration. Kubernetes is a production-grade platform for running containers reliably at scale across clusters. They overlap in orchestrating services, but they solve different problems and live at different stages of the delivery pipeline. What problem are we really solving? Most teams want three things at once: developer speed, spin up a full app locally in minutes, not hours; operational consistency, dev looks like prod enough to avoid surprises; production resilience, auto-healing, scaling, rollouts, security controls. Aspire leans heavily into the first goal and helps with the second. Kubernetes dominates the third and can support the second, but typically demands more upfront platform work. Microsoft Aspire in plain English. Microsoft Aspire is a set of tools and patterns that make it easier to build, configure, and run distributed applications, multiple services, databases, caches, queues during development. It gives you a consistent way to declare what your app depends on and how services connect. Then it helps orchestrate those pieces. The technology behind Aspire. Aspire is built around a few key ideas: an app model. You define an application composition, services and dependencies in code. For .NET teams, this usually feels natural because it's in the solution, not scattered across scripts. Service discovery and configuration. Aspire wires up connection strings, endpoints, and environment variables so services can talk to each other without lots of manual setup. Local orchestration. Aspire can run components locally and/or via containers, coordinating startup order and dependencies. Think of it as compose my distributed app for dev with strong conventions. Developer dashboard. A friendly UI for viewing running resources, logs, and endpoints. It reduces the where is that log friction. The result is a smoother inner loop experience. Change code, run the whole system, see what's happening, repeat. Kubernetes in plain English. Kubernetes K8s is a container orchestration platform. It runs your containerized workloads across a cluster of machines and handles the hard parts: scheduling, health checks, service networking, scaling, and rolling upgrades. The technology behind Kubernetes. Kubernetes is not just Docker on multiple machines. It's a control plane that continuously tries to match desired state, what you declare, with current state, what's actually running. Key building blocks include pods, the smallest deployable units, one or more containers that share networking and storage; deployments, manage rolling updates, and keep the right number of replicas running; services and ingress, stable networking for your pods, and HTTP routing into the cluster; config maps and secrets, configuration and sensitive values injected into workloads; controllers, reconciliation loops that enforce desired state. If a pod dies, Kubernetes replaces it. This is why Kubernetes is excellent for production. It's designed for reliability and scale, but it can feel heavy if you just want to run 5 services locally for development. How Aspire and Kubernetes compare. 1. Primary purpose. Aspire, developer productivity and consistent app composition for dev test. Kubernetes, production-grade orchestration and platform operations. 2. Learning curve. Aspire, generally quicker for .NET teams. You define resources and references with familiar tooling. Kubernetes, more concepts, manifests, networking, security, storage, controllers. Powerful, but you pay for that power. 3. Environment fit. Aspire, great for local dev and CI dev environments where run the whole app matters. Kubernetes, great for staging and production, multi-service deployments, and high availability needs. 4. Operational maturity. Aspire, not trying to replace a full platform ops layer. It's a dev toolset with helpful conventions. Kubernetes, a platform foundation. You'll still need observability, policy, security, and deployment tooling around it. A practical way to choose. Use these decision cues. Choose Aspire first if your pain is local orchestration, service wiring, and developer onboarding. Choose Kubernetes first if you already run containers in production, need scaling and resilience, or have multi-team platform requirements. Choose both if you want fast local development and Kubernetes-based production deployments. This is a very common end state. What it looks like in practice. Here's a simplified example of how a Spire-style composition can feel. The goal is not the exact syntax for every version, but the idea. Declare services, attach dependencies, and run. With Kubernetes, you typically package each service into a container image and deploy using manifests or Helm. Again, simplified for readability. Notice the difference in intent. Spire focuses on composing and wiring your app for development. Kubernetes focuses on keeping a declared workload running reliably in a cluster. How they work together in a healthy delivery pipeline. A sensible workflow for many teams looks like this. Develop locally with Spire. Run the full distributed app quickly, with consistent configuration and a dashboard for logs and endpoints. Build and test in CI. Package services into container images. Run unit integration tests, and validate configuration. Deploy to Kubernetes for staging production. Use a repeatable deployment method, manifests, Helm, or GitOps, with proper policies and observability. This approach reduces friction where it matters most, the dev inner loop, while still landing on a hardened runtime for production. Common pitfalls and how to avoid them. Trying to make Kubernetes your local dev tool. It can work, but it often slows teams down. Keep local dev lightweight unless you truly need cluster-accurate behavior. Assuming Spire replaces production operations. Spire helps composition and developer experience. You still need production practices, monitoring, alerting, backups, access control, and disciplined releases. Configuration drift. Even with Spire, be intentional about how settings flow from dev to prod. Define a clear strategy for secrets, environment variables, and connection strings. Bottom line, if you're deciding between Microsoft Spire versus Kubernetes, it helps to stop thinking of it as a head-to-head battle. Spire is a developer accelerator for distributed apps, while Kubernetes is a runtime platform for operating containers at scale. For many IT leaders, the best outcome is Spire for developer productivity and Kubernetes for production reliability, with a clean pipeline connecting the two. If you'd like help mapping your current architecture to a practical Spire and Kubernetes workflow, CloudPro can assist with platform design, deployment patterns, and developer experience improvements. Use dev containers for .NET development, connecting to a running container terminal, Cypher queries and RAG technology explained, developing apps for Microsoft Teams. Create a blank Neo4j instance.